Today, we are diving into a really cool, kind of radical idea for protecting some of our most beautiful and, let's be honest, most vulnerable old buildings from one of the most powerful forces on Earth. So, here's a question for you. How do you save a city from its own buildings? I know, it sounds like a weird riddle, but for so many cities around the world, it's an incredibly serious problem. When an earthquake hits, the biggest threat often isn't the ground shaking. It's the structures we live and work in, especially the older ones that just weren't built for that kind of stress.
Okay, so if the risk is that high, why haven't we just fixed all of them? Well, as we're about to find out, the real challenge of retrofitting isn't just about engineering, it's about people.
The thing is, the way we usually try to do this is not just crazy expensive, it is a total nightmare for the people inside. I mean, can you imagine having to pack up your entire life and move out for months? For most families, the cost and the sheer hassle just mean this life-saving work. It never happens.
But what if there was another way? A better way? Well, to find it, a group of researchers looked up, way, way up, to a secret technology that keeps the world's tallest skyscrapers from swaying in the wind.
It's called a tuned mass damper, or a TMD for short. And honestly, the concept is pretty simple. Think about it like this. If a building starts swaying to the left, the TMD, which is really just a giant, super calibrated weight, swings to the right. It's like pushing a kid on a swing at the perfect moment to stop it cold. That counter motion just cancels out the vibration, and the building stays stable. Pretty clever, right?
Okay, so let's get a little geeky for a second. In this diagram, you see the building, that's MB, and it's being shaken by the ground. Now, up top, you've got MTMD, that's our damper. It's engineered to swing in the exact opposite direction, acting like a perfect counterweight that neutralizes the shaking and stabilizes the entire structure.
And this isn't some wild, untested idea. The basic concept has been around for over 100 years, getting better and more sophisticated over time. But here's the catch. For its entire history, it's been a tool used almost exclusively for brand new, massive skyscrapers, with a relatively small mass designed to handle things like wind or maybe some minor tremors.
And that is where we get to the really cool part, the breakthrough. It's all about taking this proven tool and asking a totally new question. Instead of using a tiny mass on a giant building, what if we just flipped the script entirely? What if we put a proportionally massive damper, I'm talking a seriously heavy one, on top of a smaller, older, much more fragile building to protect it from a major earthquake? And just to put this into perspective for you, a normal TMD in a skyscraper might be, 1 or 2% of the building's total mass. This new idea explores using a mass that's up to 40% of the original building's mass. It is a completely different ballgame for a completely different purpose. So how would you actually do this in the real world? Well, the researchers came up with two really clever ways. First, you could literally build a whole new floor on top of the building, put it on seismic isolators, and that new floor becomes your damper. Or, even cooler, you could surgically separate the building's existing roof, put that on isolators, and turn a part of the original building into its own protector. Now, that is a fantastic idea on paper, right? But the big question is, does it actually work? Well, to find out, the researchers had to put this idea through one of the most intense virtual stress tests you can imagine. What you're looking at here isn't just a pretty picture. It represents thousands and thousands of virtual experiments. The researchers built countless digital models of this damper system, changing its mass, its stiffness, all its properties, and then slammed each and every one with simulations of 100 different earthquakes. It was this massive effort to map out every single possible outcome. And from that absolute mountain of data, they were able to create these charts, which are basically a cheat sheet for engineers. The goal is super simple. Just find the lowest point on the curve. That little dip, that's the sweet spot. That's the magic number. It gives an engineer a practical roadmap, the exact tuning they need for a specific building to get the absolute best protection without any guesswork. So what were the results? Well, they were huge. The simulation showed that the right TMD could reduce the building's maximum sway, what engineers call displacement, by more than 30%. That is a massive improvement. And this is even more impressive. It could cut the intense, violent shaking felt inside the building, the acceleration, by over 40%. In a real earthquake, that is literally the difference between a building that survives and one that pancakes. The simulation numbers are amazing, but okay, let's bring this back down to Earth.
The researchers then applied their findings to a real-world test case to see how it would all play out.
They picked the perfect candidate, a typical 4-story concrete building in Italy from the 1980s. And the key thing here, it was designed and built with absolutely zero seismic safety features. It was, for all intents and purposes, a sitting duck.
So using those charts they created, they designed a TMD with a mass that was 20% of the building's total mass, and they tuned its wobble to 1.2 seconds, that perfect sweet spot they'd found. And the result? They transformed a highly vulnerable structure into one that's significantly safer, all without ever touching the floors where people live.
And this is where it all comes full circle. We get back to the incredible real-world benefits. This approach isn't just about safety. It's a solution that could be way cheaper and so much less disruptive. The people inside might not even have to move out. And get this, if you add a new floor to act as the damper, you're not just protecting the building, you're adding valuable new space. You're literally turning a safety upgrade into a financial asset.
It really leaves us with a fascinating final thought, doesn't it? For so long, we've thought about strengthening old buildings from the inside out, or from the ground up. But maybe, just maybe, the most elegant and clever solution of all is to build our protection right on top, turning a building's own roof into its guardian angel.